Hey everybody, Dr. Phil here. So this is a video on discounted cash flow valuations. So looking a little bit more at future value and present value. So the first thing we're going to look at here is future value with multiple cash flows. So let's say you deposit $100 today in an account paying 8% interest. In 1 year, you will deposit another 100. So there's your multiple cash flows, right? How much will you have in 2 years' time? So at the end of the first year, you will have 108 plus the second $100 deposit. So think about the 108, the $100 you had initially invested plus the 8%. Then you add another 100. So you got 208. You then leave that 208 on deposit at 8% for, in essence, the second and final year. So at the end of the second year, it's worth 208 times 1.08. That's that compounding kicking in. So we have 224.64. So you can see this kind of expressed graphically here, right? Cash flow today, 0.0, cash flow another 100 a year from now. And then down here, you can see where we're multiplying it by the 1.8. So as you can see, if we do it in the timeline, we get the 224.64. So two different ways of calculating, I'm going to say FV because I always call it FV instead of future value. PV, if you hear me say PV, present value, if you hear me say FV, that is future value. So consider the future value of 2 grand invested at the end of each of the next 5 years. The current balance is 0, so there's nothing in the account right now, and the rate is 10%. So the timeline is presented below. I'm a big fan of timelines because I think it just graphically just helps you see when the cash flows are either coming in or going out. So you can see our 5 cash flows here, right? And it's at the end of year 1. That's why you have the 0 and nothing here like today. And then in a year's time, it'll be the first 2,000 will be invested, so on and so forth. Notice that nothing happens until the end of the first year, as we just said, when we make the first $2,000 investment. If we compound the investment one period at a time, then the future value ends up being 12,210 and 20 cents. And you can kind of see down here how we did that, right? So 0, there's nothing throughout year 1 because you didn't invest it until the end. So that's the 0. And then 2,000 times 1.1, so we got 2,200. Then you add another 2,000, so it goes up to 4,200 times 1.1. It then becomes, of course, 4620. Then you add another 2,000, 6620. Times that by 1.1, 7282. Add in at the end of the fourth year, the other 2,000, 9282 times 1.1 again, and then that's 10,210 and 20 cents. Add in your final 2,000, which of course that's not compounded because you're pretty much adding that on the last day, so it doesn't have any time to. And we get 12,210 and 20. So you can also solve the problem. You can also do it this way too. If you could take 2,000 times 1.1 to the power of 4, get that value. You could do 2,000 times 1.1 to the power of 3. That's what we're doing here. And then we're just basically adding all these different amounts up. And of course, you notice that we get the same answer. All right, so what about present value so we just talked a little bit about future cash flows. What about present value with multiple cash flows? So let's say you need $1,000, but in a year's time, and you need 2,000 more in 2 years' time. If you can earn 9% on your money, how much do you have to put up today to exactly cover these amounts in the future? So another way of saying that is, what is the PV, the present value of the 2 cash flows, discounted back to today's dollars at 9%? So the PV of 2,000 in 2 years at 9% is 2,000. We just divide it by 1.092. Simple enough. Again, these are the present value factors. Look at the tables. Look at the intersection of 9% in 2 years. And then below that, we've got the other present value, 1,000, and it's 1.09. Again, look at your table, present value table, and then you're looking for the intersection of 9%, and this one was let's see, it was 2 more years from then. So the end of year 2 going into year 3. So we add those together, and we get a total present value of just over $2,600. We can't do this one as an annuity because there's a gap between those years. So just bear that in mind. All right. So as with future values, there are 2 ways to determine the present value of a series of future cash flows. Number 1 is more cumbersome, which no one really ever does. Discount back 1 period at a time. Let me go back. That's kind of what we just did there. Or you can calculate the present values individually and add them up. So let's say we have an investment that's going to pay $1,000 at the end of every year for the next 5 years. So to find the PV, we could discount each 1,000 back to the present separately, and then just add them up. So that's kind of what they're doing here, right? Like at the end of year 1, 1,000 times 1.106. So think about that like the 6% interest rate. And then times 1.106 to the power of 2 for 2 years, to the power of 3 for 3 years, to the power of 4 for 4 years, so on and so forth. And then all they're doing there is they're just adding up all these values, so like the 943 plus the 890, so on, and we get that 4212. So another way we can do this is we could discount the last cash flow back one period and then just add it to the next to last cash flow. So as you can see, what we've written out here, the 1,000 over 1.06. Think about the interest rate plus the 1,000 is 943.40, and then you would just add the 1,000, and then we get 1943.40. And then we could take that 1943.40 and then just pretty much do the same thing again, right? Divided by 1.06. Again, think about the 6% interest rate, add the 1,000, 1833, add the 1,000 again, and then we get the 2833.39. And then you can just basically just keep doing that. I would say that, yeah, that's okay. You could do it that way, but let me go back. This way is probably, if you look at that graph, I would say that this way is probably easier to understand. All right, so you are offered an investment that's going to pay you 200 bucks in 1 year, 400 next year, 600 in the third year, and then 800 at the end of the fourth year. You can earn 12% on very similar investments. So what is the most you should pay for this particular one? So the way we need to do this is we need to calculate the present value of the cash flows at 12%. Okay, and that's about, and then we would of course just add them all together, right? So the first one we've got the 200 times 1 over 1.12 to the power of 1. And you can see I simplified it out, 200 over, think about that reciprocal, 1.12, 0, 0, you don't have to add that in, doesn't really matter. And then you get 178.57. And then the 400, remember this is at the end of the second year, hence to the power of 2. So 400 over 1.2544. You can use the present value factor tables to do this if you want. 600 times 1.12 to the power of 3, we get the 427, so on and so forth. So we get a total present value of 1,432 and 93 cents. So if you can earn 12% on your money, then you can duplicate this investment's cash flows for 1,432.93. So what they're basically saying there is the most you should be willing to pay is 1432.93. If it's less than that, then it's a good deal. If they're trying to make you pay more than that, it's a bad deal. You shouldn't take it. All right, so you can also do this on, this is the way most of you will probably do it, is do it on a financial calculator. So from example 6.3, that was what we just did here. They're just showing you here like how you could put these in on the keys. So like for the first one, and remember in the first year, that 200 right here, this was one time period. So you just put N is 1, interest rate per year is 12%. You can leave the payment blank and then just put in the FV as 200. And then you're just going to solve for the present value and it's going to give you that 178.57. Okay. And then next, do the same thing for the year 2. So you see now N has gone from N equals 1 to N equals 2. And then you can just put in the, you would actually need to put in the, I have a wide interest rate as 12, put in the future value 400, and it's going to give you the present value 318 and some change. So honestly, doing it on a calculator or even doing it in Excel, I'm fine with you doing that. It's totally fine. It's a lot easier than trying to calculate it by hand, and it's also a lot quicker. And that's when you get out in the real world, everybody's going to do that anyway. There's no reason for you. I don't expect you to sit there and write this stuff out by hand. All right, let's take a look. Let's take a look at another example. You're offered an investment that will make three $5,000 payments. The first payment will occur 4 years from today. The second will occur in 5 years, and the third will follow in 6 years. So if you can make 11%, what's the most this investment is worth today? So think about today like the present value. What is the, and then the second question is the corollary question. What is the, hang on a minute, let me go back. I'm not sure what I just did there. Let's see. There we are. Yeah, so what is it worth today, and then what is the future value of cash flows? So we'll answer the questions in reverse order to try to make the point. So the future value of the cash flows in 6 years is, remember we've got three $5,000 payments. So you see the 5,000 here, and then you see the 5,000 there, plus the last 5,000. There's no compounding on that because again, it's at the very end, there's no time for it to earn any interest. There's no compounding to be done. So 5,000 times 1.112 and then 0.111, right? If we add those together, we get the 6160 and 50. Then we add the 5550. Then we add the 5,000. Again, think about it, that last 5,000 is is what? There's no compounding on that because it's at the end of the period. It doesn't have time to compound. Think about it like you're adding it on the last day. So then the 16,710.50 is the future value. And then we just take that, we just divide it by 1.11 to the power of 6, because it's basically 6 periods. So the present value, or another way to say that is today's dollars, that 16,710.50 is worth 89.34 and 12 cents. So we can check this. We can just, if you wanted to, you can just, if you want to pause this, you can just look through this. This is just doing it like one at a time. This way will work as well. It's just going to take you longer to do it. But if you want to pause it right here, and if you just want to like look through it and go, okay, yeah, that's like the first year, and then the second year, and then the third year, you're welcome to do that. You're going to end up getting the same number either way. I would submit to you if I go back real quick. This way is probably much quicker. Save you a bunch of writing. And again, don't forget, you can also do this on the calculator. All right, present value for an annuity cash flow. Remember what, if you've heard the term annuity, think about like an annuity as just a series of payments, either coming in or going out that are just the same amount every period. So like a car payment, a mortgage, those are examples of annuities. Okay. So think as their definition, an annuity is a level stream of cash flows. So just think about the same period, the same payment every period for a fixed period. Suppose we're examining an asset that promised to pay 500 bucks at the end of each of the next 3 years. The cash flows from this asset are in the form of a 3-year $500 annuity. If we wanted to earn 10% on our money, how much would we offer for this annuity? So one way we could solve this is just to discount each of those $500 payments back, kind of like we did before, using the 10% discount rate. That's kind of what I'm showing you down here. So like for the first one, right, the 500 over 1.1, again to the power of 1, then to the power of 2, think about, and then to the power of 3, think about those 3 years. And then we just simplify it out and we get 1,243.43. So that's like saying $500, for each period. That is currently worth, based on a 10% rate of return or 10% discount rate. It's currently worth 1,243 bucks and some change. All right, so the present value of an annuity of what we call, we just term this C dollars per period for T periods. It all sounds very, very mathy. Don't worry, it's not difficult at all. When the rate of return or interest rate R is given by, and then we typically will use this formula. So the annuity present value is CX, or just think C times 1 minus the present value factor over R. So again, don't look at this and freak out. I promise you it's not difficult. It's just a question of plugging in the numbers. And that's kind of what we're doing here, right? So you see 1 over 1. Think about this reciprocal, 1.1 to the power of 3, and then equals, of course, 1 to the power of 1 over 1.331. And we get the present value factor of 0.751315. So what we can do with that is we can just basically plug that present value factor into the formula, right? So think about the formula, 1 minus the present value factor, so 1 minus what we just calculated, the 0.751315, and then divide it by R is the interest rate, so it was 10%, so 0.10. If you simplify the top part out in the parentheses, we get 0.248685, again over 0.10, and that comes out to 2.48685. Then what we do with that number is important because then we take the 500, think about those yearly annuity payments, and we multiply it by that 2.48, and we get that 1243. I kind of made reference to these earlier. I just wanted to just include these and just make a brief reference. These are in the book, obviously. You're going to have four tables that you're going to be really looking at. Present value of a dollar, present value of an annuity, future value of a dollar, and then future value of an annuity. Okay. So this is an example of one of the annuity tables that you'll see here. And again, you probably, once you understand these tables, it's pretty easy, right? You just look at the number of periods, you look at the interest rate. So if I'm looking, just to make an example up of, I want 15% for 3 years, I match it up, 3 and 15, and I get 2.2832. In this case, we're looking at that factor we got before, that 2.4869. And if you look, you can see the 2.4869 here. It's at the intersection of 3 periods. Remember that 500 over 3 periods. And if you remember, the interest rate was 10%. So it's just finding the intersection. That's all you gotta do. All right, so if you want to use the calculator, which that's what I'd recommend, then this is where we're using the payment key. So you can see how we plugged it in down here, right? If you remember, N was 3 periods, interest rate per year was 10%, and the payment was 500. and then we can just solve for you can leave, if you want to put the future value as 0, we'll just leave it blank. It's probably better to leave it blank. You should spit out, you should, on your calculator, you should solve for the present value and you'll get the 1243. Just remember, if it's a negative number, just remember all that. Don't worry about that. It just means that that's money going out. Positive numbers are money coming in. Negative is money going out. All right, so let's take a look at another example of finding the payments. Let's say you want to start a business. So apparently you're going to produce and market your product. It's called the Yaki Doodle Dandy. So you need to borrow 100 grand to get this thing off the ground. Because it strikes you as unlikely that this particular fad will be long-lived, you propose to pay off the loan quickly by making 5 equal annual payments. If the interest rate is 18%, 1/8, that's a very high interest rate, by the way, what will the payment be? So again, it's just a question of look at your formula, right? C times, and then look at your order of operations, 1 minus the present value factor, and then think about this reciprocal over R. So you just plug it in, right? So 1 minus 1 over 1.18 to the power of 5, because remember that we're going to pay it off in 5 periods. And then you can see the 0.18 here. So the interest rate is really in 2 places, right? 0.18 and then 1/8 again there. And then if you solve for it, once you simplify this, you get C times 3.1272. So then all we got to do is we just take the 100,000, we divide it by 3. We're just basically solving for C, right? So 100,000 over 3.1272, we get 31,977. So basically you got to make 5 payments, as it says, of just under 32 grand a piece. Or again, you can do it on the calculator. So you'd put in N as 5. Think about 5 periods. You want to pay it off in 5 years. Interest rate per year is 18%. That is a ridiculous interest rate, by the way. If anybody tries to charge you that, run a mile. That's ridiculous. Leave the future value as blank. Don't even put 0 and leave it as blank. Put the 100,000 present value, and then just solve for payments. And this is what it should spit out. Exactly the same number. And guess what? It'll take you about all of 5 seconds to do it. So hint, use your calculator. All right, finding the rates. So an insurance company offers to pay you $1,000 a year for 10 years if you will pay $67.10 up front. So the question is, what rate is implicit in this 10-year annuity? Basically, what is the interest rate? It's a fancy way of just saying that. So again, we just use our formula, right? 6710 equals 1,000 times, and then 1 minus the present value factor over R. So all we're doing is we're just plugging in the numbers, right? It's all we got to do. It's all we got to do. All right, if you look, so the way we're going to do this one, the way I want you to do this one, solve it using the annuity table, which I mentioned down here. Go find your annuity table. Look across the row corresponding to 10 periods, because remember, it's a 10-year annuity, in table A.3, and you'll see a factor of 6.7101 for 8%. Okay, so think about, we've got the 6.71 up here, right? So we're looking at the 6.71, and we're saying, all right, let's go find in our table, like, which value in our table is closest to the 6.71. And it's this 6.7101, slightly over, but that's okay. So the interest rate is 8%. Technically, it's just over 8%, but we could just say it's 8%. That's fine. Right, let's look at another example. So say a relative wants to borrow 3 grand. My advice to you is don't lend any money to friends and relatives. Doesn't usually work out very well. So she offers to repay you 1,000 every year for 4 years. What interest rate are you being offered? So you could find the answer by trial and error. So at 10%, the present value annuity factor is 3.16987, right? So then if you plug that in, multiply it by the 1,000 that she's going to offer to pay you back for 4 years, you get 3169.87, right? So then you say, all right, 10% rate of return. So then is that too high or too low? So let's look at number 3. Let's try 12%. You plug in 12%, and we get 3,037.35. So we're still a little bit low on the old discount rate. The present value is still a little bit high, right? So let's try 13% because we're trying to get it right down to 3,000. So let's see how close we can get it. So if we do 13%, we get, now it's gone, if we increase the interest rate from 12 to 13%, the value went from 30.37 at 12% to 29.74 at 13. So what we're basically just going to say is the interest rate's going to be about 12.5%. That's okay, that's fine. All right, so again, this is something that, guess what? Good news, you can do it on the calculator. So four periods, so put in N equals 4. Put in your payment as 1,000. Remember, you can leave that as a positive because this is money coming in. Put in the present value as negative 3,000 because you're lending this person 3,000 today, and then just solve for the interest per period. And there it is, 12 point. So the calculator is going to tell you exactly what it is. We did the trial and error on the last slide. Calculator is going to tell you exactly what that number is, 12.59. All right, future value for annuities. All right, so remember what an annuity is. Think about like a steady stream of payments. It could be coming in, could be going out. It doesn't matter. It just has to be the same amount each period. Okay, so let's say you want to contribute 2,000 every year to a retirement account paying 8%. If you retire in 30 years, how much will you have in the account? So look at your formula. We got the annuity FV factor down here is the future value factor minus 1 over R. So we know that it's paying 8%, so we can just put in our parentheses here 1.08. We know it's 30 years, so to the power of 30 minus 1 per the formula, and then just divide it by, again, the interest rate R. And then what do we get? We get 113.2832. Okay, so then all we got to do think of that as the sort of like the future value annuity factor, if you will. We could have looked that up in a table. It's quicker to do it this way. So then take the $2,000 yearly payment, multiply it by the factor. We get 226,566.42. So long story short, all that to say, if you pay in 2,000 a year for 30 years at 8% compounding, you will have the 226 and some change at the very end. Again, easier. Just do it on the calculator. I know I keep saying it, but please just do it on the calculator. It's way easier. Put in n equals 30 for 30 periods. Interest rate per year is 8%. Put in your payment as negative 2,000. Leave the present value. Just leave it blank. Don't even put a zero. Just leave it blank, and then just solve for the future value, and you will get the same number again in a whole lot less time. All right, so sometimes we need to find the unknown rate R. So I think what we're saying now is we're trying to figure out we're kind of trying to figure out the rate. So let's say you invested $100 a month in stocks over the 25-year period ended December 1978. Your investment would have grown to, think about this, $76,374. This period had the worst stretch of stock returns of any 25-year period between 1925 and 2019. So the question is, how bad was it? So when they say how bad was it, basically like what was the return, i.e. what was the rate? So if we take the 76,374 is equal to 100 that they invested per month multiplied by some factor, right? So what we did here is we took the 763.74, we got our formula, the 1 plus R to the power of 300, okay? And then minus 1 over R. So the annuity future value factor ends up being 1.01300 minus the 1, of course, per the formula. And then again, 0.01, just dividing it by the interest rate again. So we get 1,878.85. So what we notice is that 1%, yeah, it's not too bad. It's not too far off, but it is a little high. So moving forward from here on out, as it says, as you can see, right, it's just trial and error. All right, so a little bit about rates. So rates are quoted in many ways. So if a rate is quoted as 10% compounded semi-annually, this means the investment actually pays 5% every 6 months. Kind of what I was actually talking about this earlier part of the video. So the question then is 5% every 6 months the same thing as 10% every year? The answer is no, because you get 5% in 6 months, and then that 5% is now available to be compounded on top of. So as it says, if you invest $1 at 10% per year, you'll end up having 1.10 at year end because you're making interest on interest. Think about that idea of compounding. If you invest at 5% every 6 months, then you'll have the future value of $1 at 5% for 2 periods, which again is, as you see again, right, 1 times 1.052, so 1.1025. So in this example, the 10% is a stated or quoted interest rate. Okay, the 10.25, which is actually the rate you will earn because of the compounding, is called the effective annual rate. So that's usually going to be higher than the stated or the quoted interest rate. Okay, anytime we have compounding during the year, we need to be concerned about what that rate really is, because the rate's going to end up being higher. So to compare different investments or interest rates, we will always need to convert to effective rates to really understand like what is my investment making me as far as rate of return. So let's look at an example. So a bank is offering 12% compounded quarterly. If you put $100 in the account, how much will you have at the end of 1 year? What's the EAR? And how much will you have at the end of 2 years? So the bank's effectively offering 12% divided by 4 because they're compounding it quarterly, right? So there's your 4 periods, all within 1 year. So it's basically 3% every quarter. So if you invest $100 for 4 periods at 3% per period, the future value is 100 that you invested times 1.03, 3% per quarter, and then just to the power of 4. So if you simplify that out, we get 100 times 1.1255. So thus the investment at the end of the year will be worth 112.55. So then we would say, okay, well, considering we invested $100, sort of like overall, then we know that we made an EAR of 12.55%. Just think about what's above the 100, okay? So we can determine what you would have had at the end of the 2 years in two different ways. So the first way is to recognize that 2 years is the same as 8 quarters, right? 4 quarters in a year times 2. At 3% per quarter, after 8 years, you would have as follows. You would have 100 times, again, just pretty much the same as before, right? Times 1.03, but now to the power of 8. So now we have 126.68. So alternatively, we could determine the value after 2 years by using the EAR of 12.55%. So after 2 years, you would just have, look what I did here, 100 times 1. Think about that, 1255, i.e. 12.55% to the power of 2, because it's 2 years. And then again, we get the same number again. So it's just different ways that we can do this. Okay, so I do want to just touch on this real briefly because APR is something that you'll hear about. When you're going into the bank, getting a loan, getting a car, stuff like that. So truth in lending laws, federal truth in lending laws in the US require lenders to disclose an APR on virtually all consumer loans, much as they might not want to. So the annual percentage rate, the APR, is the interest rate charged per period multiplied by the number of periods per year. So the question then is APR the EAR? In other words, if a bank quotes a car loan at 12% APR, are you actually paying 12% interest? And the answer is you're not. So for example, on APR of 12% on a loan calling for monthly payments, it's just really 1% per month, right? Because it's 1% per month times the 12 months of the year. Okay. As you can see here, the EAR on such a loan is as follows, right? So 1 plus APR over 12 to the power of 12 minus 1 equals 1.01 to the power of 12, and then we end up getting the 12.6825. There are also what we call truth in saving laws that require banks, other credit unions, depository institutions to quote what's called an APY. So an APY is, unlike an APR anyway, an APY is like an EAR. Okay, so we think about the APY as actually factoring in all of the compounding that our investment instrument, CD savings account has done over the period. Okay, and last thing I want to talk about treasury bills. No one really ever says treasury bills, they just call them T-bills. This is, of course, issued by the US government. So this is the government borrowing money, usually on a short-term basis, a year or less. It does so by selling what are called treasury bills. So a T-bill is a promise by the government to repay a fixed amount at some time in the future. So maybe 3 months or 12 months. Treasury bills are pure discount loans. Okay, so if a T-bill promises to repay 10 grand in 12 months and the market interest rate is 7%, how much will the bill sell for in the market? So because the going rate is 7%, the T-bill will sell for the present value of 10,000 to be repaid in 1 year at 7%. So 10,000 divided by 1.07, it will just sell for 93.4579. So basically, you're going to give them 93.4579 now. They're going to give you 10,000 in a year's time. There is your 7%. Okay. All right. As always.